In 2026, a team at the University of Alabama did something that should have been impossible. They made light itself bend backward, not around a corner, not through a prism, backward through time. The lab was quiet that Tuesday morning in March. Dr. Sarah Chen stood in front of a table covered in mirrors, lasers, and what looked like a crystal ball made of pure mathematics. She pressed a button. The light beam that emerged traveled faster than light itself. And in that moment, everything we thought we knew about the universe just became up for grabs. The physics textbooks sitting on your shelf right now, they're about to become antiques. Because what happened in that lab wasn't just another discovery. It was the moment humanity figured out how to cheat the ultimate speed limit. You probably learned in school that nothing can travel faster than light, 186,000 miles per second, the cosmic speed limit. Einstein carved it in stone with his theory of relativity, and for over a century, nobody could touch it. But here's what nobody tells you about Einstein's rules. They only apply to normal space. And what Dr. Chen's team created that morning? That wasn't normal space at all. If you want to see how this story ends, and trust me, the ending will blow your mind, subscribe to the channel for more space videos. Number 1. The measurement that broke physics. The device sitting on that lab table looks like something a wizard would own. Mirrors arranged in perfect circles, laser beams splitting into dozens of paths, and at the center, a sphere of metamaterial that shouldn't exist according to everything we learned in school. Metamaterials are substances engineered at the atomic level to do things that natural materials can't do. Think of them as reality hacks. They can make objects invisible. They can bend sound waves into impossible shapes. And in Dr. Chen's lab, they made space itself act like it was running backward. The experiment was simple in concept. Shine a laser through the metamaterial sphere. Measure how long it takes to reach the other side. Do the math. The math broke. The light pulse didn't just travel through the material faster than it should have. It arrived at the detector before it finished entering the sphere. The exit happened before the entrance was complete. Dr. Chen ran the test 17 times that first day. Same result every time. The light was cheating time itself. Number 2, the phone call that changed everything. 2 months later, Dr. Chen got a call that made her hands shake. The caller was Dr. James Liu from MIT. His team had been working on something called the Alcubierre drive for the past 3 years, a theoretical engine that could make faster-than-light travel possible by bending space instead of moving through it. They'd been stuck on one massive problem: the energy requirements. To bend space enough to travel faster than light, you'd need more energy than exists in the entire observable universe, mathematically possible, but practically useless. Until Dr. Liu saw Chen's research paper. The metamaterial wasn't just making light travel faster, it was creating tiny bubbles of warped space, space that contracted in front of the light beam and expanded behind it. The exact same principle as the Alcubierre drive, but on a microscopic scale, and it was using almost no energy at all. Dr. Liu's next sentence changed everything. "Sarah, I think you just figured out how to build a warp drive." Number 3, the first real breakthrough. By December of 2026, the joint team had built something the size of a refrigerator in a warehouse outside Boston. They called it the Quantum Displacement Engine, QDE for short. The first test subject was a grain of rice. They placed it inside a chamber filled with the same metamaterial array that had bent the light beam. Flipped the switch. The rice grain disappeared from the left side of the chamber and appeared on the right side, instantly. Not fast, instantly. As in, 0 time elapsed between disappearance and reappearance. The grain of rice had traveled 3 feet in literally no time at all, but here's the part that made the entire team go silent. They analyzed the grain under a microscope and found something that shouldn't be possible. The rice hadn't aged during transport, not even by nanoseconds. Time for that grain of rice had stopped completely during the journey. They'd built a machine that didn't just move objects faster than light, it moved them outside of time. Number 4. The moment everything went crazy. Word leaked in January of this year. A video taken by a lab intern showed a coffee mug teleporting across a table. The intern posted it on social media as a joke, thinking it was some kind of magic trick. Within 6 hours, the video had 3 million views. Within 12 hours, Dr. Chen's phone was ringing with calls from NASA, SpaceX, the Pentagon, and governments from 12 different countries. Within 24 hours, the world realized that the age of interstellar travel had just begun. Because here's what a coffee mug teleporting across a table really means. If you can transport a mug instantly across 3 feet, you can transport a spaceship instantly across 3 light years. The distance doesn't matter when you're stepping outside of space and time completely. Mars isn't 4 months away anymore. It's a coffee break. The nearest star system, Alpha Centauri, isn't a 20,000-year journey. It's a weekend trip. And those exoplanets we've been discovering with the James Webb Telescope, the ones that might have life, they're no longer unreachable dreams. They're potential vacation destinations. Number 5, the race that's happening right now. 3 major programs launched in the past 6 months. NASA's Quantum Transit Initiative got $12 billion in emergency funding. SpaceX announced they're building a prototype passenger transport system. China's space program went completely dark, but satellite images show massive construction at their Hainan launch facility. The first human trials begin next month. Not with people yet, with monkeys. 2 rhesus macaques named Armstrong and Shepard will be the first living creatures to travel faster than light. They'll make a round trip to a space station orbiting the moon. Total journey time, 8 seconds. If it works, human trials begin by Christmas. If it works, your kids will grow up in a universe where other planets aren't distant points of light. They're places you can actually visit. But here's what nobody's talking about publicly: the implications that keep the scientists awake at night. If we can step outside of time during transport, what does that mean for causality? If you can arrive somewhere before light from your departure point reaches your destination, are you traveling backward in time? And if you are, what happens to cause and effect? Dr. Chen's team is working on these questions right now in a basement lab that's classified at the highest levels, because the machine that started with bending light might have accidentally created humanity's first time machine. The future isn't coming. It's already here, sitting in a lab outside Boston, humming quietly while it rewrites the rules of existence. Your grandparents lived in a world where crossing an ocean took weeks. Your parents lived in a world where crossing an ocean took hours. You're about to live in a world where crossing the galaxy takes minutes. And the strangest part? This is just the beginning. Because once you can manipulate space and time on command, travel isn't the only thing that becomes possible. Energy becomes infinite. Aging becomes optional. Death becomes negotiable. We're not just getting faster spaceships. We're getting the keys to reality itself. The universe just became a much, much smaller place, and humanity just became something we've never been before. Immortal, unstoppable, and capable of being anywhere in the cosmos before lunchtime. Subscribe to the channel for more space videos.